We've seen in other videos in this series the practical side of inspection and testing, and we've touched on certain aspects of filling in the necessary documentation. So the question we must ask ourselves is, why is there a need for a video which examines more detailed aspects of filling in certificates and report forms?
The reason is, Dave, that it's actually amazing how many errors are made over and over again by contractors when they fill in the forms. And in this video, I think it would be great if we could look at the forms for domestic installations and discuss why we need them, when they should be used, who can fill them in, and the common mistakes that I've seen over and over again.
Although today we're looking at domestic versions of the certificates and report form, much of what we're going to talk about will be common to other versions as well. Now, we've already mentioned other videos, but there's also the Inspection, Testing and Certification book available from NIC EIC, which is an excellent reference book to have in your toolbox. It not only covers the documents that we're focusing on today, but also gives practical advice on inspection and testing. So because of this, there's no need in this video to examine every single box on the certificates. We'll instead examine the areas which traditionally cause problems for contractors when it actually comes to filling them in. First and foremost, certification is a fundamental principle in the regs, required by Regulation 134.2.1, which requires that after initial verification, that appropriate certification shall be issued. In Chapter 6.3, Certification and Reporting, Section 631 details the requirements for electrical installation certificates, electrical installation condition report, and minor electrical installation work certificates.
I'll summarise the requirements in simple terms. Upon completion of a new installation or alterations or additions to an existing installation, the appropriate certification must be issued. For new installations, rewires, or the provision of any new circuit, this will be an electrical installation certificate. For an alteration or addition to an existing circuit, it will be a minor electrical installation work certificate. For reporting on the condition of an existing installation, an electrical installation condition report must be used. This was a major change introduced with Amendment No. 1 of the 17th edition and replaced the periodic inspection report as the form to be used for periodic inspection and testing.
All of these documents can be produced in any durable medium, including written or electronic media, as long as the authenticity and integrity of originals and copies can be verified by a reliable process or method. Whenever issuing a certificate or a report form, they must be supplied together with a schedule of inspections and a schedule of test results for the scope of work undertaken. Model forms for certification and reporting are provided in Appendix 6 of BS 7671, and these are adapted in a user-friendly way by NIC EIC.
Dave, we've discussed some of the requirements of the regs, but actually there's a good common sense reason for issuing certificates and report forms, and that is that these bits of paper are often the only evidence a contractor has that he's been on site, that his work was left in a safe condition and complied with the wiring regs.
It is important to understand what issuing a certificate or report form actually means. A certificate is issued to confirm that the work undertaken within its scope has been designed, constructed, inspected, tested and verified in accordance with the current national standard for the safety of electrical installations, BS 7671, the wiring regulations.
On the other hand, an EICR is to report on the condition of an existing installation and to determine, so far as is reasonably practicable, whether it is in a satisfactory condition for continued service. And if you haven't already seen it, our EICR video is well worth a watch to help you get a grip on the subject.
Good plug, Tone. Okay, so we've established why we need them. Now let's look at when they should be used. So let's start by looking at the certificates. In what situations is it appropriate to issue an electrical installation certificate, Tony?
That's a good question, Dave, because surprisingly the answer isn't as straightforward as you might think. Its most common use is for new installation work, for example on a new build project where the electrician will be confirming the standard of the work and the safety of the whole electrical installation. However, it could also be used for a rewire, a consumer unit replacement or the installation of any new circuit.
So what Tony's saying is that although it has the word installation in the title, it doesn't always mean the whole installation. It actually depends on the details and extent of the work being carried out.
Yes, obviously for a new build or where a house has been completely rewired, it does confirm the standard of the whole job. But in cases such as installing a new circuit, it only applies to the work being done.
This is why both certificates have boxes requiring a detailed description of the installation work covered by the certificate, and also a box to write comments on the existing installation. Presumably, this is a place to record any defects the electrician may have discovered with the existing installation.
Yes, but only defects which do not affect the safety of the new work. Now, of course, you've got to use your nod here. Before starting any alteration or addition, it is essential to do a pre-work survey on the installation. The survey should cover items such as the incoming supply equipment, existing earthing and bonding arrangements, and consideration should also be made for any additional loading that the new work may place on the existing installation.
With a survey, it does give the opportunity to discuss any problems with the client prior to commencing the installation.
Now, if you don't see any defects, you must write the word none here.
If you're going to use a domestic electrical installation certificate, there are 4 conditions which must be met before it can be used. The first is that the electrical installation work relates to a single dwelling.
So that's a house or an individual flat. It's not a block of flats or the landlord's supply.
Secondly, that the design, the construction and the inspection and testing of the electrical installation work has been the responsibility of one person or organisation.
If it isn't the responsibility of one person or organisation, then our full electrical installation certificate will have to be used, which provides boxes for each relevant person to sign.
The third and fourth requirements are that the installation forms a part of a TT, TNS or TNCS system, and that the protective measure for fault protection is provided primarily by automatic disconnection of supply, ADS. And moving on to the minor domestic electrical installation work certificate, for what types of work should this be used?
The minor work certificate may only be used for an addition or an alteration to a single circuit that does not extend to the provision of a new circuit. So, for example, you might use it when extending an existing circuit, say a ring final circuit into an extension. But you have to use a minor work certificate for each and every circuit you work on. So if I also extended a lighting circuit into that very same extension, I would have to use 2 minor work certificates. And if the extension was a kitchen and I extended the existing cooker circuit into it, I'd have to use yet another one.
So what you're saying is that in the example you've just described, instead of 3 minor work certificates, it would make much more sense to use an electrical installation certificate and list the details of the circuits being worked on in the details of the installation box.
Exactly. But one final word on the certificates. Neither of these are used on their own to certify the commissioning of powered smoke and heat detectors. If you are installing these, then as well as the appropriate electrical certificate, you will have to issue an installation and commissioning of a fire alarm system in dwelling certificate to cover these devices. On the domestic electrical installation certificate, there's a box titled Schedule of Additional Records, where the details of additional certificates can be recorded.
Let's move on to the electrical installation condition report. When are these used?
Periodic inspection and testing is a growth industry, with reports being requested by landlords, local authorities, estate agents and increasingly homeowners when selling or purchasing a property. An electrical condition report is, as it says, a report on the condition of an existing installation. It is not a certificate and should never be used as one.
Due to the efforts of organisations such as the Electrical Safety Council, householders and people that are looking to buy houses are becoming more aware of the implications of poor electrical wiring, not only in terms of safety, but also the potential costs of a rewire and the redecoration if you buy a property without checking the quality of the wiring first.
Dave, I got a friend that fell into that trap. Before he bought a house, he did not check out the electrics. You should have known better.
Yes, if you want to see the story of my money pit, check out the video Think Electric, available from the Electrical Safety Council. So now, let's look at who should fill out and sign the forms. All three of the forms we're focusing on today are filled in by the person who undertook the work.
As you can see, we've got two sets of boxes for signatories. One for the qualified supervisor and one for the person who's responsible for the design, the construction and the inspection and testing of the installation.
In many cases, for example, if you're a sole trader, these boxes are going to be signed by the same person. However, in a larger company, the person responsible for the design, construction and inspection and testing will sign one set of boxes, and the results of the inspection and testing will be reviewed by the qualified supervisor who'll sign the other boxes.
The important thing to remember, Dave, that whoever fills them in must be a competent person. That doesn't mean they need to have letters after their name or even be registered with an organisation such as the NIC, although it does help. And it means that they will have sufficient technical knowledge, relevant practical skills and experience for the nature of the electrical work undertaken. And of course, they will be able to prevent danger for themselves and others at all times.
The final thing to talk about with regards to signing the forms is the responsibility placed upon those who do sign them. I've heard some contractors express concern about signing a certificate or report because they believe they may be confirming the whole installation is safe when their contract was only for a part of it. It's therefore important to remember when you sign these that the scope of the work undertaken is clearly indicated and described in the details of installation box on the certificates and the extent of limitations boxes on the condition report form.
In other words, you are only signing for what has been done and certainly not for work which has been carried out previously.
In this section of the video, we're going to examine some of the common parts of the forms which often either cause confusion or are filled in incorrectly.
The first thing to look at, Dave, are the boxes which require names and addresses. Each form has an area for the client's details, the address where the work is to be carried out, and also the company details of the contractor doing the work.
Sometimes it's possible that the client's address and the address where the work is being undertaken will be the same. So what's the acceptable way to fill in the form in that situation?
It's perfectly acceptable to write in the address location, same as client's details or something similar.
Okay, let's move on to supply characteristics.
Supply characteristics is relevant to all three forms, but more information is required to be filled in on the electrical installation certificate and the electrical installation condition report.
One of the things that can be a bit misleading here is that the boxes for supply nominal voltage are blank, which has often invited the recording of the actual measured voltage.
The reason why it's blank is that there are many variables for a circuit or installation. The supply could be AC or DC, single or multi-phase. It could even be ELV. So whatever you're working on, these values must be recorded.
As we can see, there are two boxes with nominal voltage written next to them, one identified with U and the other with U0. For public supplies in the UK, U is 400 volts and U0 is 230 volts for two-phase and three-phase supplies. For a single-phase installation, U should have not applicable and U0 should have 230 volts.
And remember, you must never record a measured voltage in these boxes.
Next we have nominal frequency, and again this is a blank box. But in the UK this would typically be 50 Hz. There are preferred frequencies listed in the regs, including 60 Hz and 400 Hz. For example, although rare, you might encounter 60 Hz on American Air Force bases located in the UK.
The final box included with supply parameters is external earth fault loop impedance, ZE. Now on the domestic electrical installation certificate, this is not a measured value, but a declared value determined by inquiry to the electricity distributor or taken from the design information.
The declared value of ZE for a TNCS supply is 0.35 ohms, and for a TNS supply is 0.8 ohms.
However, on electrical installation condition report, it requires just a measured value. Now, if we look back at the domestic electrical installation certificate, we can see that there is another box for a measured value of ZE as well.
The reason why the electrical installation certificate has both an inquired value and a measured value is to confirm that the intended means of earthing is indeed present, and also that the design criteria is accurate. For example, if your measured value of ZE was considerably higher than that of the value found by inquiry, it could have a knock-on effect on earth fault loop impedance value ZS for the final circuit, which would be higher than those calculated by the designer, possibly meaning that the specified circuit protection will not operate in the time required by the regulations.
The next thing to consider is prospective fault current. The forms do allow us to either determine this by inquiry or measurement. However, I would normally expect the boxes under supply characteristics to be filled in with the data from the design information. This, on most occasions, will be values determined by inquiry. Typical values are 16 kA for single-phase supplies and 25 kA for three-phase supplies.
On the EICR and domestic EIC forms, there's an additional box under test results for the actual measured value of prospective fault current. Because measured values are usually considerably lower than those obtained by inquiry and displayed in amps on some test instruments, it may on occasion be necessary to convert the readings of PFC from amps to kiloamps. This can be done by dividing by 1000. So for example, 1456 amps becomes 1.46 kA.
Don't forget as well that the prospective fault current is the highest value obtained from either the prospective short circuit current test or the prospective earth fault current test, and this is for each supply if there's more than one.
It's important to mention that some instruments will not be suitable to measure prospective fault currents on three-phase supplies, so check your instrument can before you do.
If your instrument doesn't, it doesn't matter, because it's perfectly acceptable to measure prospective short circuit current between each phase and neutral and multiply your highest reading by 2 to give an approximate value of prospective short circuit current for the three phases.
The next box, which some may find confusing, is number and type of live conductors. Now here we can see a number of boxes labelled as one phase 2 wire, one phase 3 wire, etc. So can you give us a quick overview, Tone?
Well, in a house, the most common box to tick is the one phase 2 wire. So we have two live conductors, line and neutral. One phase 3 wire relates to a single phase split phase supply, 230 to 460 volts. This is not common, but you could encounter it, say on farms, where a higher voltage may be necessary to operate some machinery. Three-phase 3 wire is often used in larger installations to supply motors and has 3 line conductors, one for each phase of the supply. And finally, we have three-phase 4-wire, which has 3 lines and a neutral. This will be for commercial, industrial and the larger domestic installations.
When you've filled in the appropriate boxes with a tick, it is good practice to put the letters NA for not applicable in the remaining boxes. The only part of the forms which actually lists putting not applicable as a requirement is the schedule of items inspected. Nevertheless, it is a good idea to do this throughout the rest of the document. Let's look now at the characteristics of primary supply overcurrent protective device. The first box requires the BS-EN number for the device. Typically, in a domestic installation, this will be either a BS1361 cartridge fuse or a BS88-3 fuse System C, which was introduced with Amendment number 1. For larger installations, you might find a moulded case circuit breaker, or in very old installations, a BS3036 semi-enclosed rewirable fuse. For new installations, it should not be a problem determining the characteristic of the device, but for an EICR, it can often be difficult to ascertain, and in some situations will have to be an agreed limitation of the report.
The next box says type. Now I've seen this filled in as new one or grey one, but what it's actually referring to is the type of the characteristic of the device. There is data available to help you determine the type of device in the on-site guide.
For example, a BS1361 fuse used as a primary supply of a current protective device will be type 2. The next 2 boxes are rated current and short circuit capacity. The rated current is fairly straightforward, as it's the rating of the fuse or circuit breaker.
Short circuit capacity, on the other hand, is the maximum fault current the device can interrupt safely. Looking back at the data, we can see that a BS1361 Type 2 fuse has a rated short circuit capacity of 33 Ka. And it's this value which must be higher than the prospective fault current we spoke about earlier.
There's a good point of warning here. On a periodic, if you did encounter a 3036 rewirable fuse as the primary supply overcurrent device, this could have a rated short circuit capacity as low as 1000 amps, depending on its designation.
The next group of boxes deals with the means of earthing. Now, if you have an earth provided by the electricity distributor and you tick the distributor's facility box, there is no need to fill in the remaining details about the installation earth electrode, other than to write none or not applicable.
This should also reference the system type box. So, for example, if you've ticked TT, you should not have a tick in the distributor's facility box. However, you should insert a tick in the installation earth electrode box. If you're on a TT system, you'll have to fill in the remaining details about the installation earth electrode. The acceptable types of earth electrode are listed in Regulation 542.2.3. It will also be necessary to measure and record the electrode resistance RA, and you must also write down how this was measured, because there are several test methods that can be used. For example, where there's a supply, a loop impedance tester may be used, or where there's no supply, by using an instrument and proprietary earth electrodes to undertake the fall of potential method.
However, recent developments in test equipment have also introduced a new non-invasive test where there is no need to disconnect the earthing conductor or connect to live terminals. You can instead use clamps. So an overall safer approach to obtaining the earth electrode resistance.
Remember that the resistance value you get should be as low as practicable, and that values above 200 ohms may become unstable, particularly in dry or frozen conditions.
Finally, for earth electrodes, we have location. Now I've seen this filled in with outside or in the ground, which isn't very helpful to the person who comes along for the next EICR. So it's better to write down a fixed point of reference. For example, 1 metre from the kitchen window, or as we can see in this picture, 1.5 metres from the side of the garage.
The next box to examine on the certificates deals with protective measures for electric shock. Now this in most cases is automatic disconnection of supply, ADS, but can be followed by one or more of the protective measures detailed in Chapter 4.1 of the regs. So for example, double or reinforced insulation could be recorded for a circuit supplying a non-metallic hand dryer, which is a common example of equipment adopting this protective measure. Next, let's look at boxes referring to protective conductors.
First, we have the earthing conductor. The conductor material will generally be copper, but it could be aluminium or steel, and the cross-section area needs to comply with the requirements of Regulation Group 542.3 and Section 543. Here you will find detailed information on how you can either select a suitable cross-section area or calculate it.
Within the section concerned with protective conductors, there is a box to confirm that both the connection and continuity of the conductor has been verified. This could either be a visual means of checking continuity or confirmed by testing.
Just to let you know that when we say visual check, we mean that you can see the entire length of the conductor. So even though it might only be for a couple of meters, if it passes through a wall at any time, you will have to confirm continuity by measurement. Next, we have the main protective bonding conductors. Conductor material will most likely be copper, and the cross-section area must be what you actually see on site, not the design information where you have it. There are several tick boxes for the various extraneous conductive parts. For example, water, gas or oil. You would expect to see either a tick or an NA in each box, but for an EICR, you might also have a limitation or an outcome code referring to the urgency of the remedial action required, which we will discuss later. Any limb you write must be fully detailed in the limitations box on the front of the EICR form.
Let's now look at the section for main switch or circuit breaker, which you won't find on the minor work certificate. Here we can see